Usually, when you trace the lineage of a breakthrough technology, the timeline is, it's remarkably clean.
Right, you can usually point to a specific lab or an exact date.
Exactly. You look back, you find the engineer, and you mark the exact calendar date when the silicon caught up with the theory.
Like the microchip or the smartphone.
Yeah, they all have these definitive binary starting lines. But the moment you look at the infrastructure behind virtual reality, augmented reality, and the so-called metaverse, that clean historical timeline just
It
shatters.
completely falls apart.
It does. You aren't looking at a straight line of computing progress. You're looking at a century-old, relentless human obsession with sensory deception.
Which is wild to think about.
Right. And it was completely constrained by the physical limits of whatever hardware was available in any given decade.
It really is less of an engineering timeline and more of a, well, it's like a psychological ghost story.
Oh, a ghost story. I like
Right.
that.
Yeah, because the ambition to step entirely out of the physical world and into an illusion didn't start in a modern Silicon Valley boardroom. It's this ancient desire.
Right. We've always wanted to escape reality.
Exactly. And if you, as a listener, are trying to understand where the current multi-billion-dollar math tech investments are actually pointing, you have to look backward.
You really do.
You have to understand how we've been trying to hack human perception long before we had the microprocessors to actually pull it off.
Which is exactly our mission for you today. We're going to cut through the modern marketing hype to shortcut your learning curve on these massive industry shifts.
It's going to be a fun one.
Definitely. And to do that, we are diving into a really fascinating 2022 presentation by Julian Alvarez.
Ah, yes.
Yeah, it was delivered at the Immersive Training Encounters, the Rencontre de la Formation Immersive. The presentation is just titled AR, VR, XR, Approaches and Uses in Training.
And to even begin unpacking this, we really have to establish the taxonomy.
Oh, for sure. The corporate jargon right now is just completely muddying the waters.
It's a mess. Companies use AR, VR, XR, and metaverse interchangeably, basically depending on what they're trying to sell you.
Right. But Alvarez points us to this rigorous academic framework from 2014. It was established by researchers Jessel and Alvarez to anchor these concepts.
And that 2014 framework is vital because it strips away all that marketing fluff. It focuses purely on the cognitive relationship between the user and the environment.
So let's look at virtual reality first, or VR.
Right, so Jessel and Alvarez define VR as an interactive, immersive experience where a user, through computer tools, perceives a synthetic environment.
But the critical operative mechanism here is belief, right?
Exactly. Belief. The system's entire architecture is designed to give you the ability to believe you are truly present.
Like interacting with simulated objects as if they had actual physical mass.
Precisely. You feel the consequence of the space.
And the source notes reveal this really fascinating evolution in how we even talked about this state of belief.
Yeah, the early terminology is super interesting.
It is. Because before the industry locked in the term virtual reality, early pioneers were tossing around names like artificial reality or cyberspace or synthetic environments.
And Alvarez points out that the common philosophical thread running through all those early names is the concept of plunging the individual.
Plunging, that word is just so deliberate.
It really is. You aren't just passively observing a screen.
Right, you're crossing a cognitive threshold where you and, potentially thousands of others are completely submerged into a shared alternate physical logic.
But compare that plunging mechanism to augmented reality, or AR.
Totally different vibe.
Fundamentally different psychological goal.
Yeah.
With AR, you aren't subverting the user's primary reality, you're supplementing it.
Right, so AR relies on spatial computing to anchor digital images onto the physical environment in real time.
Exactly. You remain cognitively anchored in the physical room, but the room is enriched.
So then the framework defines extended reality, or XR, not as a separate piece of tech, but just as the overarching association.
The umbrella term.
Yeah, the entire spectrum where virtual and real environments intersect. Okay, let's unpack this for you with a quick analogy.
Let's hear it.
So AR is like sticking digital Post-it notes on your actual physical fridge.
Okay, yeah.
VR is stepping entirely inside a digital fridge. And XR is just the giant umbrella covering all these weird fridge experiences.
I love the fridge analogy, but what's fascinating here is that despite the changing jargon, the core psychological goal hasn't changed.
Not at all.
From synthetic environments to the metaverse, it's a static biological reality. The human brain interprets the world through specific sensory inputs.
And if you can hijack those inputs with enough precision, You create a shared illusion.
The goal has never changed, just the tools.
Which brings us to the actual timeline. Because the origin of the sensory hijacking is, frankly, shocking.
It goes back way further than people think.
Way further. If you assume the quest for the metaverse began with early computer graphics, you were ignoring a massive chunk of the story.
Oh, absolutely.
The foundational concept of tricking the brain into perceiving a 3D synthetic space actually originates in the late 19th century.
We're talking about stereoscopic photographs here.
Yes, the Victorians.
Right. The mechanics of 19th century stereoscopes basically exploit binocular disparity.
Because our eyes are set slightly apart.
Exactly. Each eye receives a slightly different angle of the world, and the brain fuses those two flat images into a single perception of depth.
And those Victorian inventors realized that if you take two photographs from slightly offset positions
And present them simultaneously through dedicated lenses.
your brain's visual cortex will just automatically run that same depth calculating algorithm.
It was a purely optical hack. No electricity required, just an understanding of human biology.
Which is brilliant, but, completely static. You're still just staring at a frozen moment in time.
Right, there's no movement.
So the leap from a static illusion to an actual immersive environment happens in 1962, decades before miniaturized computer processing.
This is where we get to Morton L. Heilig?
Yes, and his creation, the Sensorama simulator. The photographs of this device in the presentation are incredible.
It looks like a massive retro-futuristic arcade cabinet.
It really does. And Heilig understood that true immersion couldn't just rely on the eyes.
No, the Sensorama was this exercise in brute force mechanical immersion.
It was designed to simulate a motorcycle ride. Right.
Yeah, and to achieve that, it used a 3D stereoscopic color display with wide peripheral vision, stereo sound, and a vibrating seat.
But it went even further than that.
Oh, way further. It had mechanical fans to blow physical wind in your face to simulate velocity.
That's amazing.
And it even had a chemical mechanism to release specific aromas, like exhaust fumes or blooming flowers, all synchronized to the film strip.
Okay, I have to push back here, though. I have to challenge the inclusion of the Sensorama in the lineage of VR.
Really? How come?
Well, based on the 2014 Jessel and Alvarez framework we just discussed, VR requires an interactive experience through computer tools.
Right, interactivity is key.
And the Sensorama was essentially an incredibly complex mechanical playback loop. You couldn't turn the handlebars of the motorcycle and choose a different path.
True.
It blew perfume in your face, sure, but it was basically a 4D theme park ride crammed into a single user cabinet. It completely lacked the computational reactivity that defines modern VR.
And that is the exact boundary line the presentation is drawing.
Oh, it is?
Yes. The Sensorama represents the absolute limit of what mechanical engineering could achieve in sensory deception. It gave multisensory input, but you're exactly right. It offered zero user agency.
So when do we pivot from mechanical playback to actual reactive environments?
That happens later in the 1960s with Ivan Sutherland.
Ah, the CGI pioneer.
Exactly. He conceptualized the first actual head-mounted displays that tracked user movement.
But Sutherland hit a massive physical wall because the human imagination had finally conceptualized the digital space, but the hardware of the 1960s was, frankly, brutally unforgiving.
The main bottleneck was miniaturization.
Because of the monitors.
Yeah, to render graphics that could react to a user's head movements, you needed cathode ray tube monitors.
And those are just completely made of glass and copper.
Right, they're incredibly heavy.
Yeah.
So Sutherland's headsets were so massive that a human neck literally couldn't support the weight.
So what did they do?
The archival photos show this massive rig, colloquially known as the Sword of Damocles.
Such a dramatic name.
Well, the user is strapped into a headset that is literally suspended from the ceiling by a heavy mechanical arm.
That sounds terrifying.
It does. And the arm isn't just holding the weight, it's physically tracking the orientation of the user's head to tell the computer how to update the wireframe gravrons.
It's the perfect visual metaphor for the era. The software was ready to transport you to another world, but the hardware physically tethered you to the ceiling of a laboratory?
Exactly. So the engineering mandate for the next few decades became obvious.
Detach the screens from the ceiling. Shrink the components until they can comfortably sit on the bridge of a human nose.
Which sets off this really fragmented race across different industries to commercialize the illusion.
Starting with toys, right.
Yeah, in the 1970s, the concept reached the mass market purely as a toy. The iconic Red Viewmaster.
Oh, I had one of those.
Most people did. It took that 19th century stereoscopic concept, packaged it in cheap plastic, and put it in millions of living rooms.
It completely normalized the idea of holding a device to your face to see a 3D world.
But while the toy industry was normalizing the concept, the industrial sector was trying to make it useful.
Like NASA in the 1980s, the sources note they were developing the first functional VR headsets for astronaut training.
Right, and the images show these incredibly bulky, opaque visors.
Well, they needed a safe way to simulate complex zero-gravity manipulations before putting billions of dollars into actual orbit.
And, as always, whenever government labs pioneer visual tech, the gaming industry immediately tries to monetize it.
Naturally.
So throughout the 80s and 90s, we see a flood of ambitious but deeply flawed commercial attempts.
Like the Vectrex 3D Imager in 1982.
Exactly. The Tommytronic 3D in 83 and the Sega VR project in 93.
The gaming industry really wanted to deliver cyberspace.
Yeah.
From all the sci-fi books of the era on consumer-grade hardware.
But they just didn't have the processing power.
And that rush to market culminated in 1995 with one of the most infamous hardware failures in consumer tech history.
Oh, the Nintendo Virtual Boy.
Yes. For context, this wasn't even a headset you wore. It was a heavy plastic console resting on a bipod. You had to hunch over it and press your face into it.
Sounds incredibly uncomfortable.
It was. And the presentation shows exactly what the user saw. A deeply jarring, entirely red and black wireframe display.
Just pitch black and neon red.
Yeah, you were playing tennis in a void of neon red lines.
Huh.
And according to the source, the failure of this specific device essentially marked a massive halt for VR in video games.
Julian Alvarez uses a very specific French term for the aftermath of 1995.
Essoufflement.
Essoufflement. What does that translate to?
It basically means a profound loss of momentum, a collective running out of breath. The industry had hit another physiological wall.
The hardware ambition had just vastly outpaced the silicon. So what does this all mean? We went from literal rocket scientists at NASA in the 80s to kids getting headaches playing red wireframe Mario Tennis in the 90s. Did the gaming industry just bite off way more than the tech could chew?
Absolutely. But it wasn't just bad graphics. Bad graphics don't kill a hardware category for 15 years.
Sure.
The real issue was physiological rejection.
Ah, the nausea.
Exactly. When you look at the specs of the Virtual Boy and early 90s headsets, the refresh rates and display latency were terrible.
Because there was a delay. Right. In physical reality, you turn your head, your inner ear feels the motion, and your eyes instantly confirm it. But in those early VR systems, you'd turn your head, the inner ear registers movement, but the computer needed a fraction of a second to render the new frame.
And that microscopic delay is everything. When the visual data lags behind the vestibular system, the brain interprets that mismatch as a neurotoxin.
It literally thinks you've been poisoned.
So the biological response is to induce nausea so you expel the poison. Plus, you had that vergence accommodation conflict causing severe eye strain.
Consumers abandoned it because their bodies physically rejected the illusion.
Which proves that if you fail to respect human biology, the illusion shatters immediately.
Completely.
But visual latency was only half the equation. Let's look at the other major sensory input.
Touch. This is a huge piece of the puzzle.
Right, because if you render a perfect, lag-free digital room, and you reach out to grab a digital coffee mug, and your hand just passes through empty air, feeling absolutely nothing.
The brain instantly flags the environment as a simulation.
The visual immersion is immediately broken by a lack of physical resistance.
And this is a vital component of the Alvarez presentation. VR isn't just about optical hardware, what the French call visio-casques or headsets.
True immersion relies equally on haptic sensors.
Exactly. The system needs to provide tactile feedback to close the sensory loop.
And here's where it gets really interesting. Gaming paved the way again, right? The source points to the Nintendo Power Glove in 1989.
Yeah, in the same era we were struggling to render a basic 3D cube, engineers were already trying to digitize the physical human hand.
It's the difference between just looking out a window and actually being able to open the door. They understood that immersion requires agency.
It can't just be a floating camera.
Right. You have to project your physical anatomy into the machine to manipulate the data.
Now, the Power Glove was rudimentary, but when you compare it to the modern haptic tech highlighted in the presentation, you see the staggering leap in engineering.
Oh, the music glove.
Yes. Alvarez focuses on modern haptic gloves optimized specifically for playing digital music.
Because to play a digital piano, the latency has to be 0.
Exactly, and the tactile feedback must be incredibly precise.
The technical breakdown of these gloves in the slide deck is just a masterclass in biomechanical engineering. They aren't these thick, cumbersome gauntlets.
No, they leave the fingertips completely free.
Right, so the musician can still interact with physical instruments seamlessly.
And they feature an open palm design, which is critical for keeping the hand cool.
Plus, it allows the user to naturally clap or just feel the physical world.
But woven into that fabric is an incredibly dense array of sensors,
Like the vibration motors for localized haptic feedback.
simulating the resistance of a plucked string or a drumstick. And they have 8 separate bend sensors across the knuckles to capture the subtle flexion of the fingers.
And most importantly, they use an IMU, an inertial measurement unit. Let's break down the IMU, because that is really the unsung hero of spatial computing.
It really is. It's the same tech that tells your smartphone which way is up.
Exactly. An IMU combines microscopic accelerometers and gyroscopes to constantly calculate pitch, yaw, roll, and absolute acceleration in 3D space.
It tracks the exact speed and trajectory of your hand in real time.
Combine that with the bend sensors, and the computer knows exactly where your hand is, what shape it's making, and how fast it's moving.
The gloves even include RGB LEDs to give instant visual confirmation when a haptic trigger is activated.
And all of this runs wirelessly. It's a profound shift. We went from a 1960s headset hanging from the ceiling to a wireless tracking fabric you slip over your knuckles.
But this level of tracking requires immense computational power.
Right, and we know the 90s winter was caused by weak hardware. So what finally brought VR back from the dead? When was the inflection point?
The presentation identifies 2012 as the dawn of the modern renaissance.
2012.
Yeah, that was the year VR finally broke the winter. And the catalyst was a convergence of 2 things: new, lightweight stereoscopic lenses, and crucially, smartphones.
Because the smartphone industry effectively subsidized the miniaturization of high-res screens and mobile processors.
Exactly. Suddenly, computers were small enough and fast enough to render 3D environments at high refresh rates, eliminating the lag that caused the nausea in the 90s.
And the market data in the source shows an immediate violent reaction to that hardware breakthrough.
The DigiCapital charts.
Yeah, projecting from 2016 to 2021, the sales perspectives are staggering. It was this massive wave of adoption across mobile AR, VR, and high-end console VR.
The technology finally worked, so capital flooded the space.
And headsets exploded. Oculus, HTC Vive, PlayStation VR.
And with the hardware finally capable, developers faced a new question: what should we build?
Right.
The presentation highlights a major shift in March 2018, driven by Epic Games and the Unreal Engine.
Focused on cutting-edge graphics, right?
Yes. The new holy grail was to recreate the real world as accurately as possible. Photorealism became the standard for immersion.
Okay, but looking at the presentation slide titled Need for Realism, I have to ask a philosophical question here.
Go for it.
Does the human brain actually require an Epic Games ultra-photorealistic environment to feel immersed? Or did the early vector graphics and the mechanical fans of the Sensorama prove that our brains are incredibly easy to trick?
That is the ultimate debate at the heart of the XR industry.
Because I feel like as long as it reacts to us instantly, we'll buy into it.
If we connect this to the bigger picture, the push for graphical fidelity is impressive. But history shows us that presence is dictated by the feedback loop.
Not the pixel count.
Right. If you're in a low-polygon, cartoonish virtual room, but every time you turn your head, the perspective shifts perfectly, and your haptic glove vibrates the exact millisecond you touch a digital wall.
Your brain will accept that cartoon world as reality.
Exactly. Conversely, if you are in a photorealistic digital forest, but your digital hand clips through a tree trunk with 0 physical resistance, the illusion collapses entirely.
Immersion is achieved through interactivity, not perfect fidelity. What a phenomenal through line.
It really reframes everything.
It does. Our mission today was to give you a shortcut to understanding the mechanics behind these massive tech buzzwords. And mapping out this history changes everything.
We didn't just look at a list of gadgets.
No, we traced a century of human ingenuity trying to hack our own biology. From exploiting binocular disparity with 19th century stereoscopic photos.
To the mechanical, perfume-blowing overload of the Sensorama.
We saw Ivan Sutherland tethered to the ceiling because of the sheer weight of cathode ray tubes.
We analyzed how latency caused the 90s hardware crash.
And how modern IMUs and haptic fabrics finally closed the sensory loop.
The hardware is incredibly sophisticated today, but the underlying ambition is identical to the 1800s.
Exactly. So for you listening, the next time you see a tech giant claiming they've just invented the metaverse, you now know the truth. They are just iterating on the latest chapter of a century-old human quest to step inside our own imaginations.
And looking at that trajectory leaves us with a necessary question about where this ends. For over 100 years, the engineering challenge has been building devices powerful enough to trick our physical senses into believing a digital world is real.
Right, perfecting the illusion.
But as extended reality systems become seamlessly integrated into our daily lives, blending synthetic environments with our physical ones through XR with zero latency, the challenge shifts entirely.
How so?
The question is no longer whether we will believe the virtual world is real. The question is whether we'll eventually lose the biological ability to recognize what's actually physical.
Wow. That is exactly the kind of thought that will linger the next time you slide a headset over your eyes. Thank you for joining us on this deep dive, and we'll catch you on the next one.